Welcome back again to new focused approach to mathematics basic 8. This is the revised edition, and in this video we are looking at the laws of indices. Talk of indices, all we are trying to say is if we have multiples of a particular number by itself, let's say I have 2 times 2 times 2, I can write this as 2 to the power 3. That is 2 to an exponent of 3. In indices, we call this whole thing power. Okay, and the result here will be just 8. Okay, now the number here is called base, and the up number here is the index or exponents. Okay, exponent. So that is what we are going to look at. So we are going to be playing along with this kind of work, right? So again, if I have 5 and then raised to an exponent of 4, I can call this as my base, and this is the index again, or exponent. Exponent. Now, when we have plural form of index, we call it indices. Good. So now let's take the laws of indices. Let's say I have 3 to the exponent of 4 and times 3 to the exponent of 5. What it means is that the 3 to the exponent of 4 simply means I'm multiplying 3 4 times. And so 3 times 3 times 3 times 3 4 times. Then times another 3 times 3 times 3, also 5 times. When I put all of them together, I'm going to have 3 to the power 9 because there are 1, 2, 3, 4, 5, 6, 7, 8, 9 of the 3. So I can write it like the 3 exponent 9. Now, what it means also is that if I have 3 exponent 4 times 3 exponent 5, instead of writing them one after the other like the multiple repeated multiplication, you can just write 3 exponent 5, 4 plus 5, which will still give you the 9. And so with this, we can come out with a law and say that, okay, anytime I have a number to an exponent times the same number to a different exponent, I can just write one of the numbers and then add the exponent. Example can be, say I have 3 to the power 2 times 3 to the power 3, or 3 exponent 2 times 3 exponent 3. I can easily write 3 exponent 2 plus 3, which will give me 3 exponent 5. As simple as that. That is the first law of indices. Or I have 5 exponent 4 times 5 exponent negative 2. I just write 5 exponent 4 plus negative 2, which of course I can add the exponent and have 5 exponent 2. It makes it very simple, right? Okay, let's do the second law. Now, before the second law comes, there's a warning here. You see, when we have 5 exponent 2 times 5 exponent 4, we say this will give us 5 exponent 6. But when there is plus here, it means you can't apply the principle and say this is going to be equal to 5 exponent 6. When there is plus here, the law does not work. It's a warning. Don't make this mistake. The law number 2, we call it the quotient law. The quotient law also says that, okay, it's directly opposite. If I'm dividing two numbers with different exponents and the bases are the same, I could just subtract the exponent and get the result. For example, if I say 3 exponent 4 divided by 3 exponent 3, I'm going to write 3 exponent 4 minus 3, which of course will give me 3 exponent 1. But the number to an exponent of 1 is the same as the number, so we keep it like that. Again, if I have 7 exponent 4 divided by 7 exponent negative 2, because I'm dividing and the bases are the same, I'll keep one base and then subtract the exponent, which will be 4 minus negative 2, and that will give us 7 to the power 6. Let's take another caution here. When we are doing subtraction, let's say you have 5 exponent 6 minus 5 exponent 2, we can't say that will give us 5 exponent 4 by we subtracting, whilst we have the subtraction, we're subtracting the exponent. So far as this is not division, okay, if it is division, then perfect. If it's not, then you don't do subtraction. Nothing can be done if it is minus. Okay, now let's take law number 3. Law number 3 says that, let's say I have a number, okay, to an exponent already, then all together has another exponent. What we are saying is that we just have to pick the number and multiply the exponent, and that becomes the answer. For example, if I have 7 exponent 3 all to the power 4, then we can just write 7 exponent 4 times 3, and that will give us 7 exponent 12. Finally, if we have, let's say, x exponent 5 all to the exponent of 3, we can easily write x exponent 5 times 3, which will give us x exponent 15. And here too, let's take this warning as a caution. If we have 4 times 2 exponent 3, don't rush to multiply 4 times 2 and write 8 to the power 3. It won't work. And this is the reason. If I simplify this, I'm going to have 2 exponent 3 we know is going to give us 8. That's 2 times 2 times 2, which will give us 8. And we are saying that this should be equal to 8 to the power 3. Assuming we are saying they are equal, 4 times 8 will give us 32, whilst 8 to the power 3 will be 8 times 8 times 8, which of course will give us 5, 1, 2. So we can see that they are not the same, so we can't conclude. So it means that when you have a work of this sort, don't multiply this by this. Always do the indices first before you multiply by the number that follows, right? So be careful with that. Now let's look at other laws or properties that works with indices. There's a law we call power of a product rule. What it means is that it's very close to that of the third law of indices. That if I have this, okay, it means that each of these elements here can be expanded by the exponent. So that if I have maybe 5 times maybe x to the power 2, it means I will have 5 squared times s squared. Each of them will take the exponent. Again, if I have maybe 7 exponent 2 times maybe 4 exponent, let's say 1, all to the power 3, then I can expand this as 7 exponent 2 times 3 times 4 exponent also 3. That is what this law is all about. Okay, so in future sometimes the words become a bit complex, and then they can tell you that, okay, simplify maybe 2a squared all to the power 3. This simply means you're going to get 2 to the power 3, then a to the power 6. So this is how it's going to look like. So the 3 here will take care of the exponent here, and then the 3 again will take care of this exponent as well. So we get this. Then the next law, which says that the power of a quotient law. What it means is that if the numbers are divided, okay, then they all have an exponent, common exponent. The exponent must affect both the numerator and the denominator. For example, if I have 2 over 7 all to the power 3, I can easily write 2 to the power 3 divided by 7 to the power 3. That's what it means. Okay, so we can simplify that. Again, if I have a question like maybe 3m squared over, let's say, 5 and all to the power let's say 5 again, then I can have this one. 3 can take care of the 5. 3 will have an exponent of 5. M will have an exponent of 10 because the 2 is there already. All divided by 5 also have an exponent of 5. Then we simplify it from there. Good. Let's take another one. We have what we call zero power law. Zero power law. And this, what it means that every non-zero number raised to the power 0 is 1. So if I have 5 raised to the power 0 is just 1. If I have negative 21 raised to the power 0, I'll just write 1. If I have x plus 7 raised to the power 0, I can easily write 1. That is what it means. Now let's take the last one. The last one is called the negative power law. Negative power law. If you have a number raised to the power negative exponent, it simply means a reciprocal of the number to the exponent of the m positive. So if I have 2 to the power negative 3, I can easily write 1 over 2 to the power 3. I hope it makes sense. If I have, let's say, 17 raised to the power negative 4, it simply means 1 over 17 raised to the power positive 4. That is what this law also is about. Okay, so I'm sure you've now gotten the fair idea about indices and then their laws and properties. In our next video, we are going to look at how we can apply them in solving questions. Thanks so much for watching.